Today is May 19th, and what we're going to do is the volume using the washer method. So yesterday we did the disk method, and so today we're going to do the washer method, okay? And I want to do some coloring here, okay? So this is a washer, okay? And I'm going to shade it and color it in so you can see it better, okay? This would be, actually I'm going to pause this and I'll come back, okay? So here we go. All right, I figured you guys didn't need to watch me color, okay? So this is going to be our big radius, okay? This big one, right? The outer one, right? And some people call this the outer radius and then the inner radius, right? And this is going to be little r, okay? So over here, okay, and the area of this would be, the area would be equal to pi big R squared. That'd be the whole thing. That'd be the disk, right? And then we got to remove this inner circle, right? So minus pi little r squared, okay? Now, as you turn it, there's actually thickness to it, right? So the volume right here, we're going to call dx. And what we're going to do is make those like paper thin, like really, really thin, right? And this is this big R right here. It's just twisted so it looks a little bit shorter, but it's not, okay? This is big R and this is little r. So this is the outer radius and this is the inner radius, okay? So the volume of this would be pi big R squared minus pi little r squared. Okay, so that would be the area of it, right? And then we got to multiply by the thickness of it, which is dx. Okay, if we're making these discs vertically, okay, then it would be dx. If we're making them horizontal, okay, I said disc, but I meant washers. If we do the washers horizontal, okay, and we stack them horizontally, then it's going to be dy. Okay. All right, so let's talk a little bit more about how we're going to set up our integral, okay? Because we're going to integrate this, and what it's going to do is it's going to sum them all up, okay? And add all of those, like in area, it adds up all the rectangles, right? And here it's going to, if we integrate, it's going to add up all the washers, okay? All right, so let's talk about that. Okay, so for this one right here, we're going to revolve about the x-axis. So we're going to rotate around this, right? And we're going to rotate this shaded region, okay? And this top curve right here, the blue one, okay, we are going to call f of x. That's f of x, okay? And this red one right here, we're going to call g of x, okay? And we're talking about the area rotated, or the area in between, and we're going to rotate about the x-axis. So what happens is there's a gap in here, right? There's a gap between the line we're rotating around, the axis of rotation, okay, and the region we're rotating. There's an empty space in here, right? So when we do that, it's gonna form this hole in here, okay? So again, you're gonna do this, okay? It's the same as yesterday, but what you're gonna do is you're gonna go perpendicular to the axis you're rotating to the furthest one away, okay? And so going all the way to the furthest one away from the axis of rotation would be this, okay? And that is going to be my big R, okay? And then I'm going to draw another one because we have another radius, right? But it's going to be that's the outer radius, okay? And we're going to draw another one to the closest function, and that's my inner radius, and that's little r, okay? So my big R, this big R would be top minus bottom. So this is y equals 0. So it's going to be f of x minus 0, and that'd be big R. Big R is f of x minus 0, okay, which would be just f of x. Little r would be g of x minus 0, which would be just g of x. So big R is f of x and little r is g of x, okay? All right, so we're actually ready to integrate this, okay? So the volume for this would be, and I should have said this, okay, we bring this down. That's where I'm going to start creating them, and I'm going to stop creating them right here, and I forgot to draw that in, okay? And this would be B. Okay, so we're going to integrate from A to B. That's when we want to start collecting them, right? And we're going to stop collecting here at this B value, okay? Okay, so it's going to be pi big R squared minus pi little r squared, and I'm going to put parentheses around that, and dx. Okay, So then the volume, V, is equal to the integral from A to B, and then we're just going to replace, right? What is big R? Big R is f of x. So it's going to be pi times f of x squared minus pi times g of x, because that's my little r, right? Squared, and I'm going to put a bracket around this, and then dx. Okay, there's one more thing that we could do. Okay, we could, all right? You wouldn't have to, but these both have pi in common, right? So we could factor out, and since pi is a constant, we could write this as pi, the volume could be pi times the integral from a to b of f of x, and then we would need to square that, and then minus g of x, and then we would need to square that, okay, and then dx. Okay, so big R squared minus little r squared, okay? You could write it that way. I like this because it shows the area, right? The two areas that you're subtracting, and then that area times your thickness, okay? All right, I would start with this and then go to this if you want to, okay? All right? Okay, so what if we rotate it about the line like y equals k, right? So this is going to be, and let me draw this in right this time, okay? This right here is point A, and this right here is point B, and this right here is going to be the line y equals k. So it's going to be like y equals 3 or y equals 5, okay? And it is above, right, the region we're rotating. So we're going to take this shaded region, and let me slide this up just a little bit. We're going to take this shaded region, right, and we're going to rotate it around or about the line y equals k. So this is the twirling line, right? That's what we're rotating around, okay? So I always want to go perpendicular to that because that's going to be the radius. The radius will always be perpendicular because you're turning it around this thing, okay? So I'm going to draw it perpendicular to the curve that's farthest away, which would be this one. And I should say this right here, the red one is still going to be g of x. And the blue one is f of x, okay? So if I draw from this, I would have to, for the big radius, I'd have to draw all the way to g of x, okay? To the one furthest away. That's my outer radius, okay? That's my big R. Okay, my inner radius is to the closest one. So I'm going to come and go straight down to this, all right? And that's going to be my little r. Okay, so what is this big radius? Okay, how long is this? Well, we want to keep it positive, right? So we want to take this top, which is k, and minus g of x, because that's the one furthest away. This is g of x, okay? So that means my big R is k minus g of x. And there's no way you can simplify that, okay? And we're doing the idea of top minus bottom, okay? Then to get the inner radius, okay, the inner radius would still be top minus bottom, but it's going to be k minus f of x. Okay, and now because we have our radiuses or radii, the outer radius and the inner radius, big R and little r, we can find the area of one of these. Okay, all right, and then so this becomes the volume V becomes the integral from A to B of pi big R squared, right? Minus pi little r squared, and then dx, right? I mean, that's always going to be the formula for this, okay? When you have this empty space in between the line you're rotating. If you wanted to rotate everything, the whole thing, like between g of x and k, then that wouldn't be a washer, that'd be a disk, okay? Like if we didn't have f of x here, okay? All right, so here we go. This is also equivalent to the integral from a to b of pi times big R, and big R is k minus g of x, so parenthesis, k minus g of x, close the parenthesis, squared, okay? That would give me a disk, and then that's the outer disk, right? And then we have to remove the inner disk, right? Which would leave a washer, okay? So minus pi times the inner radius, right? Which is little r, k minus f of x squared, okay? And then we could put a bracket around this, and then dx, and that's the thickness of these, okay? So these would go down to the thickness of like just dx, okay? Now, an alternative way is you could, once again, factor a pi out, okay? So v is equal to, I'm going to always write it like this, okay? So v is equal to pi times the integral from a to b of k minus g of x squared minus k minus f of x squared, and then dx. I'm going to put a bracket around that. Okay? Here's a problem with this one. This one, you lose the idea of what's going on because that pi came out, right? You can see the area here, and you can see you're subtracting in this area, and I just like this one better, okay? This is more of like, I've memorized a formula to do this, okay? And this one shows I understand what's going on, okay? All right, so we have the outer circle, right? So we have the area times the thickness, okay? And then minus, and this is the area of the inner circle, right? Times the thickness, which would give you volume, okay? All right, let's go to the next page. Okay, so we want to find the volume of the solid formed by revolving the region bounded by the graphs of y equals the square root of x and y equals x squared about the x-axis. Okay, so we're going to rotate around the x-axis. So we're going around this, right? Okay, now this one right here, okay, is y equals the square root of x. And this one is y equals x squared, okay? And can you see, if I rotate this shaded region around the x-axis, there's a gap in here, right? There's a gap between the shaded region and the line I'm rotating. If there's no gap, we're gonna use washers. I said the wrong thing. We're gonna use discs. Because there's a gap, there's an outer radius and an inner radius, right? And because there's an outer radius and an inner radius, that's a washer, okay? So I'm gonna switch right now before we set this up. I'm gonna go and I'm gonna show you, I use a program to show you the rotation of this, okay? Like I did yesterday, okay? Okay, so what you see is the region that we're talking about. You know, on our paper, this is the gray. This green part is the gray, okay? And so what I'm gonna do is I'm gonna create volume, okay? And I'm gonna create volume, and we're rotating about the x-axis, which is y equals 0. That's why I'm typing in y equals 0 here. Okay, and there we go. This is what it looks like. Okay, so now I'm going to rotate this around to help us see, okay, because it looks solid right now, right? But if you look inside, it's kind of hollowed out, right? And this is a perfect example of the washer method, okay? Okay, I'm trying to get it to rotate. Come on. Okay, I'm going to animate. Zero to 2 pi, okay. And there we go. Okay, now I'm going to do something. I'm going to do something real quick, okay? I actually want to edit the area. There we go. Okay, so I want to make these rectangles, okay, just so you see those, you see the discs, okay? That's what I want you to see first. Okay, so there we go. We're doing 5 discs, okay, and I'm going to rotate this back. Come on. There we go. So you see the disc, right? And we're just going to do more and more. And what we do is the more you make, the dx, right, gets smaller and smaller and smaller and smaller, okay? And then once that thickness goes to 0, right, that's what an integral does, okay, we would have it. Okay, so now you really see it, hopefully. And it's just coming around, right? You just got to give it a chance to come around. And there we go, and then it starts over again. Okay? And there we go. Okay, and then if you, I'm gonna make these go to like infinity, okay? Okay, and then when you animate it, you see this, right? I'm gonna pause it and then rotate it again, and you can see it, okay? All right, so we're gonna find the volume of this. Now, a lot of times when you're using the washer method, okay, it's best to use technology to integrate it because you have to square, right? And you have to, a lot of times you're gonna have to square a difference or something like that, okay? All right, so let's go back to our paper and we'll work this one out. So we're rotating around the x-axis, right? And okay, so we want to go perpendicular to that to the furthest one away, which would be the square root of x. So I'm going to go all the way across. This is going to be my big R, all right? And then so this will be the space we're rotating along with the empty space, okay? And then the little inner radius is just going to be the empty space, and that's going to be little r, okay? So if we take this one minus this one, we'd be left with the in between, right? Okay, so what is big R? Well, because we're going vertical, it's going to be the top, which happens to be the square root of x, minus, and this would be y equals 0, right? The x-axis is y equals 0. So it'd be the square root of x minus 0, which would just be the square root of x. And the little r would be x squared, the top minus the bottom, right? And 0, right? So x squared minus 0, which is just x squared, okay? And so from that, I could determine my area, right? If of the washer, of one washer, the area of one washer would equal pi big R squared minus pi little r squared, okay? And my big R would be the square root of x. So this would be A is equal to pi times the square root of x squared minus pi times x squared squared, because that's your little r, okay? So we're ready to go, okay? We're gonna start making these washers right here at 0, and we're gonna end it right here at this x equals 1. So the volume will equal the integral 0 to 1 of pi big R, which is the square root of x squared, minus pi little r, which is x squared squared, and then dx. I'm going to put a bracket around that. Okay, I am going to clean this one up a little bit, okay? So from here, we could, this is the circle, right? The big circle, the little circle, and the thickness of it, okay? So what I'm going to do is I'm going to factor out a pi out of this. So pi times the integral from 0 to 1. And then the square root of x squared is just x. So this is going to be x minus, and this would be x to the 4th. Because x squared squared is x to the 4th. And then times dx. Okay? Now, we could do this by hand, right? Heck, let's do this one by hand. We'll do all the rest by technology, okay? So I'm going to slide it up just for the heck of it, right? Right. You guys are saying you're crazy. Okay. So pi times the integral. Well, actually, let me go ahead and do it, right? Because we're ready. What's the antiderivative of x? It would be x squared over 2. So we have pi times x squared over 2, okay, minus x to the 5th over 5. Close that, and we're going to evaluate this from 0 to 1, right? Okay, so this would be pi times 1 squared over 2 minus 1 to the 5th over 5 minus pi times 0 squared over 2 minus 0 to the 5th over 5. Well, all of this is going to be 0, right? So we can ignore it now from here on out. But you got to write this, because I don't know if you forget it or if you know it's supposed to be 0, right? So you got to write it to show somebody, okay? So this would be pi times 1/2 minus 1/5, okay? Common denominator is 10. Okay, so this would be pi times, and so this would be 5 over 10, and minus, and this would be 2 over 10, which would make 3 over 10, right? So this becomes 3 pi over 10, 3 pi over 10, and that's the volume of it, okay? And that's how you do these, okay? They're kind of fun once you set them up. I mean, the integration sometimes is like a bear, so that's why we use technology, okay? Especially when it's not, like these, you could square really easily, right? But when you have to like expand the binomial or something like that, like, okay, let's just use a calculator, okay? All right, so let's go to the next problem. So for this one, example 2, we want to find the volume of the solid formed by revolving the region bounded to the left by x squared plus y squared equals 25, okay? So this right here, okay, is the equation x squared plus y squared is equal to 25. That's the equation of a circle, right? And bounded to the right, so this shaded region right here, okay, so this is the bounded on the left, bounded on the right by x equals -3, so this is x equals -3, okay? And then we want to revolve it about the line x equals 1. Okay, so this is x equals 1. And we want to rotate it or revolve it about that one, right? Okay, so we are going to have to go horizontal, right? Which means our equations need to be x equals equations, okay? So we got to take x squared plus y squared. Before we do anything, we got to take x squared plus y squared is equal to 25. And we need to solve it not for y, but for x, because we're going horizontal. So we're going to pick a y to put in to get the x value, okay? All right. Okay, so I'm going to draw, okay, so this is the line we're rotating. So my radius, okay, is going to go all the way to the furthest one. So I'm going to have to go to the left, right? And so this right here would be my big radius, okay? And then from here to here would be my little radius, my inner radius, right? So this would include, okay, all of this region, okay? All right? Okay, so we need to solve this for x, right? So it would be x squared is equal to 25 minus y squared, square root both sides, right? And you get the absolute value of x is equal to the square root of 25 minus y squared, which means x is equal to plus or minus the square root of 25 minus y squared. Okay, now when x is positive, that's this side, right? Okay, so this side right here is x is equal to the square root of 25 minus y squared, which means from here to here, this is the part where x is equal to negative, right? So this part right here is x is equal to negative square root of 25 minus y squared. Okay, now, and then this is x equals -3, right? So our big radius, our outer radius, right, would be this length right here, and we want it positive. And so we're going to want to do the right minus the left. So this is the right, which would be 1, minus the left, which is the negative, right? So 1 minus negative square root of 25 minus y squared. Well, what happens when you subtract a negative? You actually get a positive, right? So big R is really 1 plus the square root of 25 minus y squared. That's my big R. My little r would be, again, right minus left. So it's going to be 1 minus this equation, right? And this equation is always, it's x equals -3, right? So 1 minus -3. That'd be 1 plus 3. So little r is equal to 4. Okay, we're ready to go. Okay, so well, I take that back. We're not ready to go. I just lied. Okay, we need to figure out this point right here. Okay, because we got to start integrating at this y value, right? And we're going to start collecting them, right? And we're going to end it at this y value. So I know the x values, right? But what are the y values? Okay, well, I know from this equation, right? I can get the, or actually this equation, x squared plus y squared is equal to 25. I can get, okay, the y value, okay? So I forgot about that, okay? Because that's where we're gonna start creating these, and this is where we're gonna stop creating these. So this would be like our A and our B, okay? So I know x is -3. So that would be -3 squared plus y squared is equal to 25. Because I have this equation and this equation, all right? So this would be 9 plus y squared is equal to 25. That would mean y squared is equal to 16. And so y could be plus or minus 4, right? I didn't go into the whole absolute value thing, okay? All right, so this point right here, we now know is the x coordinate is -3 and the y coordinate is -4. And this one, the x coordinate is -3 and the y coordinate is +4. Okay. And hopefully everybody's okay. I mean, this, like, look at this. This is cool stuff. Like if you showed somebody this, like, man, you're smart, right? Okay, because you guys are. All right. So the volume of this would equal the integral, right? And it'd be, we're gonna start making these at -4, and we're gonna stop them at 4. So -4 to 4 pi big R. So I'm going to kind of skip some stuff. Okay, so big R would be this 1 plus the square root of 25 minus y squared, right? So in parentheses, 1 plus the square root of 25 minus y squared, put the big R in parentheses, and then I have to square it, right? And let me slide it up so you can see it. Okay, and then minus pi times, okay, my little r, right? And my little r is 4, right? Squared. And then I'm going to put a bracket around it. You actually wouldn't have to, okay? And then dx. Okay? So I'm going to put it into the calculator just like this. So I'm going to go to my graphing calculator and okay, and I'm going to show you what this is equal to. Okay? Okay, so we're going to integrate. So it's going to be number 4, right? Doing that a lot. Okay, and we're going to go from -4 to 4. And then what we're going to integrate is pi, and then times, and it's my big R, right? So 1 plus the square root of 25 minus, and it's going to be x squared because we can't do y. Whoa, 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 whoa. Okay, hold on. I forgot we're in a different mode with Calc BC right now, so I got to switch. Okay, we're in polar mode, so that's why it gave me a theta. I want to be in function mode. Sorry about that. Okay, and so back over here, that's going to make, when I type this, it's going to not be theta, it's going to be x. Okay, so there we go. Okay, so 1 plus the square root of 25 minus x squared. Okay, I need to get outside this parenthesis right there, right? And I need to square it. Okay, so that's pi big R squared, right? And then minus pi little r, right? So I'm going to use parentheses, 4, close the parenthesis, and square it. Okay, so that's pi times big R squared minus pi little r squared, and then the thicknesses of each are going to be dx, right? And we put that in our calculator, and we get 338.344. Okay, so 338.344. Okay, so I'm going to go back and record. Okay, so the volume here would be approximately 338.344. Okay. All right, guys, I'm going to show you this on my other program real quick, just to show you the volume of it, and we'll be done with this one. Okay, so here's the same graph, okay, just on a program, all right? And what we're gonna do is here's the area that we're talking about, and we're gonna rotate it around this line right here, okay? So I'm gonna create volume, and we're gonna rotate it about x equals 1. Okay, and this is what it would look like, okay? So if we rotate it, trying to rotate it, okay, you can see it's almost like a bead, huh? Okay, and you can see that it's a wash. Well, it's a washer because this whole part has been hollowed out, right? Okay, and so we can go back. I'm going to animate this. And there we go. And we're rotating about this red line right here. And it creates this volume, okay? And this is with like the paper thin washers, okay? Like super thin washers. And there's like a gazillion of them, just a ton, okay? All right, so let's go to the last example now. Okay, so what we want to do up in this one is, again, set up an evaluated integral that gives the volume of the solid formed by the region bounded by the y-axis, okay? And x equals negative y squared plus 4y for 1 less than or equal to y less than or equal to 4, and then revolving the region, right, this gray region, about the line x equals negative 1. So this would be x is equal to negative 1 right here, this vertical line right here. And we're rotating around that. So you always got to determine the line you're rotating around, right? Okay. And then this equation right here is x is equal to negative y squared plus 4y. We know this is 1 from this, right? And this top is 4, okay? And this line, this vertical line right here, the y-axis is x is equal to 0, okay? All right, so this is the line we're rotating around. So now we're going to draw perpendicular to that all the way to the furthest curve away, which would be this one right here, right? So what's the distance? What's this horizontal distance between here, okay? And now we got to go to the closest one, right? Which would be the y-axis. So this is, I should label it, this is big R. And then from here to here is your little r, okay? And now we can figure those out because we're going to do right minus left, okay? So big R, I should write in red, big R is equal to this negative y squared plus 4y minus the one on the left, which is negative 1. So minus negative 1, okay? So that means big R is equal to negative y squared plus 4y plus 1, okay? That's big R. Well, what's little r, right? So little r is the one on the right, which would be 0 minus negative 1. So 0 minus negative 1. That would make 0 plus 1, or 1. Okay, so now we have our big R, we have our little r. Okay, we know where we're going to start integrating at 1, and we're going to stop it at 4. Okay, and we're ready to go to set up the integral. Okay, so let me slide this up a little bit. Okay, and so the volume of this that we're talking about is going to be equal to the integral from 1 to 4 pi big R, right, which is negative y squared plus 4y plus 1. So negative y squared plus 4y plus 1, close the parenthesis, squared. This is the area of the big circle, right? And then minus the area of the little circle, which would be pi little r, right, which would be 1 squared, right? And then we could put brackets around that. And then dx. Okay, so this, I'm going to clean this up just a little bit, okay? So this is equal to the integral from 1 to 4 pi times negative y squared plus 4y plus 1. Okay, and then square that, right? Now this is a perfect example. Like, okay, let's not do this by hand because I'd have to square this, so I'd have to multiply it out. That's going to take some time, right? What I wanted to clean up is this. What's 1 squared? it's just 1. So this is just minus pi, okay? And I can put brackets around that or parentheses, and then dx. And now we're just going to put that in our calculator and get the volume of this, okay? So it was approximately, and then we'll go to our calculator and put this one in. Okay, so for this one, what we're going to do is we're going to do integral, right? And then from 1, or number 4, and then from 1 to 4, and then pi, and then parenthesis for our big R, right? And it's negative x squared plus 4x, and then plus 1. And then close the parenthesis and square it, okay? And then minus, and just pi. And then dx. And press enter. And we get 152.681, okay? We'll record that and we'll be done. Okay, so the volume of this was 152.681. Okay, and that's it for today. And let me get the assignment sheet and we'll go over that one. Okay, so this is May 19th. I want you to do page, oops, this should be say page 411. Okay, and then 15 through 24 all. So the rest of these, okay. All right, guys, and I'll send the page. I have a picture of the page that I'll send out to you guys. Okay, you guys take care. Have a great day. See you later.